In this lesson, we're going to look at the amines and the amides, which are groups of organic compounds that contain a nitrogen atom, in addition to the carbon and hydrogen and oxygen that we've been looking at so far. So starting with the amines, these are organic compounds that contain a nitrogen atom which is attached to one or more hydrocarbon chains. And an amine can be thought of as an ammonia molecule where one or more of the hydrogen atoms have been replaced by alkyl groups. So the ammonia molecule is a nitrogen covalently bonded to 3 hydrogens. So if we replace one of those hydrogens with an alkyl group or a hydrocarbon chain, we get a primary amine. If we replace 2 of those hydrogen atoms with an alkyl group, we get a secondary amine. And if all 3 hydrogens are replaced with alkyl groups, it is a tertiary amine. We're just going to focus on the primary amines in this lesson. So how do we name those primary amines? So the name has 2 parts. The first part is amino. It's indicating that nitrogen group. And then the second part is the name of the parent alkane. When there are more than 2 carbons in the molecule, you need to indicate where the nitrogen atom is bonded using a number that indicates the carbon that it's attached to. So if we look at an example, so the first thing we're going to do is we're going to count the carbons. So there are 5, which means that this is based on a pentane molecule. And then we can see that that amino group, the NH2, is attached to the second carbon. So we would call this 2-amino pentane. Now, how do we draw primary amines? Similarly to the other compounds we've been drawing, you're going to start by creating the carbon backbone of the appropriate length indicated by the name. Then we're going to add that amino group, the NH2, at the appropriate location as indicated in the name, and then fill in the rest with hydrogens to make sure that each carbon has a total of 4 bonds. So if we use the example of 1-amino hexane, we start with a carbon backbone of 6 carbons for the hex part of the name. The 1 tells us that the NH2 is bonded to the first carbon. So you can put that on the first carbon or the last carbon. It's still carbon 1 because you can count from any end. So I'm going to put it on the last carbon. And then I'm going to fill in all the hydrogens. So there we have 1-amino hexane. And if you're like me and you're getting tired of drawing hydrogens, you can use a condensed structural formula. It's with the CH3 followed by the 5 CH2s and then the NH2. So if you had the amino group on a different carbon, you would just put that NH2 within the condensed structural formula after whichever carbon it is attached to. The molecular formula for this one is C6H15N. So moving on to the amides. So an amide is an organic compound that contains a carbonyl group, that's C double bonded to the O, which is then single bonded to a nitrogen atom. So this is the general formula where you've got a hydrocarbon chain, or that R could actually just be a hydrogen in the case of a single carbon amide. Then you've got the carbon double bonded to the oxygen, which is single bonded to the nitrogen, which then is bonded to 2 other either hydrogens or carbons. So in this example, you can see we've got the carbonyl group and then the bonded to a nitrogen, and that's what makes it an amide. Amides can be formed when a carboxylic acid reacts with an amine or when it reacts with ammonia in a condensation reaction. Okay, so this is similar to the esterification reaction we looked at in the last lesson. It is also a condensation reaction. So the carboxylic acid and the amine react. 2 hydrogens and an oxygen are removed to form water, and a bond forms between the 2 molecules to create the amide. Amides are also classified according to the number of carbon atoms that are attached to the nitrogen. So when the nitrogen's attached to only the carbon of the carbonyl group, and there are 2 other hydrogens, this is a primary amide. When the nitrogen is attached to another alkyl group and only 1 hydrogen, it's a secondary amide. And when the nitrogen is attached to all carbons, it is a tertiary amide. And like with amines, we're going to just look at the primary amides. So these are named by changing the ending of the parent alkane to -amide. So if we look at this example, we have 3 carbons in this molecule, which means that the parent alkane is propane. But at the end of it, we have this C double bonded to an O, bonded to an NH2. So that's that amide group. So we're going to call this propanamide. And you don't need any numbers with the primary amides because by definition, that C double bond O NH2 will always be at the end of the chain. Now, how do we draw the primary amides? So again, we create that carbon backbone of the appropriate length. Then we're going to add the carbonyl group and the amino group to the last carbon, or the first carbon if you prefer. And then fill in the rest of the bonds with H so that each carbon has a total of 4 bonds. So if we look at an example hexanamide, so that hex tells us that there are 6 carbons. On that last carbon, we're going to add the double bonded oxygen and the amino group, the NH2. And then we're going to fill in everything else with hydrogens. So there we have the structure for hexanamide. You can also give a condensed structural formula, the CH3, and then the 4 CH2s, and then you write the amide group at the end as CONH2. Finally, the molecular formula for this compound would be C6H13NO. So that's an introduction to the organic compounds, amines, and amides, and how we can name them and draw them.